Okay, so we're looking at a video solving equations where sine and cos appears together. We haven't done sine and cos together. We've had sine or cos or tan. So now we're going to do some ones. So I'm actually going to take you through the theory because just having the formula won't make a lot of sense. So just to start off with, I've got two right angle triangles and I have an alpha and a beta. So I want you to find the expressions. First of all, you need to find the missing side using Pythagoras. Okay, and then I want you to find sine, cos and tan for both those triangles. So pause, and when you're ready, come back live. Okay, so using Pythagoras Theorem, you've got square root of a squared plus b squared, which is the same. The only difference is the a and the b have switched over. So tan is a over b, sine is a over a squared plus b squared, b over a squared plus b squared, and for this one tan beta is b over a, sine is b over a squared plus b squared, and a over a squared plus b squared. Okay, so that's hopefully what you got, otherwise you've just seen me do it. Okay, let's come across. Okay, so I've transferred the information across from the first page, so we're just going to do the one with the alpha first. And so the equation that we're looking at is something where you've got some numbers of sines and some numbers of coses. And I put the cos first for a reason, even though on the first page I had the sine first. So if you just follow through my logic, and then we'll see how it works. So this is what we're trying to simplify, and later on we're going to solve equations. So the first thing I'm going to do is I'm going to put this number out the front, and that's the same as 1. So I haven't changed anything, and then I've just transferred that number into the bracket. And then what I'm going to do is I'm going to move the denominator, the denominator inside, so that it sits underneath, the a and the b. Okay, so you've got that pink line, so that's pretty straightforward. And then what you need to do is then look up here and see what we've got. So we've got this expression here, which is the same as sine alpha, and I've got that expression there, which is the same as cos alpha. So I've introduced now, got rid of the a and the a squareds and b squareds inside the bracket. I've still got this a squared plus b squared out the front, but that's fine, that's just a number. Now if you have a look at that side inside the bracket, you've got sine, cos, sine, and you've got those numbers the same. And we know that from our the angle sum formula, that when you have sine, cos, sine with the same numbers, okay, then you've got sine alpha plus x. Now, we can have x plus alpha, because we can add, it's the same thing, we can have them in different order. And so we've got this number out the front, and now we've got this sine x plus alpha, but alpha is tan minus 1 a on b, where a and b are the coefficients of cos and sine. Okay, so copy that and come across, and we'll do the next one together. Or you can do the work yourself. Okay, so this is the one with beta. Okay, so I've transferred the information from the first page, and I've set you up with the same sort of lines, and I want you to have a go at these 3 lines and see what you find. So again, to start off with this number here, which is 1, and then I want you to have a go and see if you can get a nice little relationship at the end. So pause, and when you're ready, come back live. Okay, so the first thing hopefully you did was you brought in a squared plus b squared cos x plus b over a squared plus b squared sine x, and then you had to look upstairs and say, oh, this time I've got cos beta, cos x, and then you've got sine beta, sine x, and now you've got this cos, sine, which you also know is one of those relationships. But now it's going to be, now I'm going to just transfer these numbers to like cos x, cos beta, I can switch the order, but when you've got a plus in between, it's a minus. Okay, so now you've got this another neat relationship where this time beta is tan minus 1b on a, where you've got, again, b and a are the coefficients of sine and cos respectively. And now we have a relationship that's not sine, we now got a relationship that's cos. I say copy that across, and then we'll just do a summary, and then we'll look at some examples. Okay, so here's the summary. Okay, you've got 2 formulas that have sine, and it just depends if you've got a plus in between, then you have a plus in between. If you have a minus in between, you have a minus in between. where tan minus 1, alpha is tan minus 1 a on b. But then you've also got the same formulas can be turned into two causes, just depending. Okay, so if you have a plus in between, it's a minus in the bracket. If you have a minus in between, it's a plus in the bracket. Okay, so you'll have those on your cheat sheet, so it won't be too difficult, but there's some nice neat formulas. Now let's have a look at some examples on how to use them. Okay, we've got about 3 examples. Okay, so the first thing we do, the first one is it tells you that this relationship, now it doesn't matter that sines before cos, we'll just change that anyway, but they tell you they want the sine, they want you to use sine, not cos. So first of all, I'm just going to put the cos first and the sine second because that's what all the formulas had. And so the first thing is this number out the front, and this number out the front, that's your a squared plus b squared. So when you do that, you end up with d equals 5. And then we've got tan minus 1 a over b. Okay, so we end up with tan minus 1 3/4, which on your calculator is 36 degrees and 52 minutes. So that means that this original equation actually ends up being 5 sine x plus 36 52. And from that, we could solve an equation, or we could sketch the function. So even though we started with what looked like 2 different things added together, we just end up with a normal sine function. So we could solve from that we could solve an equation, or we could sketch the function. Okay, so let's copy that and come across when you're ready. Okay, so let's have a look at sketching. Okay, so now we've got sketching cos x minus root 3 sine x. And so we can use either the sine or the cos. It's up to you which one you want to do, because they're going to end up with the same excuse me, the same graph. So the first thing we do is we have to get this a squared plus b squared to start off with, and we end up with just the way the numbers were chosen. We end up with a equals 2, beta equals tan minus 1 b on a, and that's one of your exact values, which gives you pi on 3. Okay, and so the original function ends up being 2 cos x plus pi on 3. Now we know that the original, okay, so this number here, that gives you your amplitude, and this at the back is your phase shift, and there's not a change in period because you just got a single x. So the original function for cos starts at the top. Okay, so I'm just doing the original, what an original cos x would look like. Okay. So that's what cos of 2 cos x would equal. Okay, so we've got 2 for the amplitude. And then all we're going to do is this plus number here just moves everything back. Okay, so instead of starting at 0, it's going to start at minus pi on 3. So all the numbers just come back. I'm not going to do all the calculations, but you just have to do, like for instance, that number there would be pi on 2 minus pi on, okay, I'll do this calculation for you. So that's 3 pi on 6 minus 2 pi on 6. So we could work out all these new values, but basically I'll just change colours. So that number is being pushed back, being pushed back, being pushed back, being pushed back, being pushed back. So and now we've got to come down and just finish that off to there, because it'll be on the downward slope. So if the function was being drawn from 0 to 2 pi, then we would just draw from there, and we'd finish at the same heights. Okay, so this little part here, we wouldn't you'd draw it in, but then you wouldn't have to show it at the end. But you've definitely got to come through to 2 pi. Okay, so copy that and come across. Okay, so this is our last example, and we've got the expression, but now we've got an equation, so it equals a number. Okay, so from the previous example, I've chosen this one again because we've already done that calculation, and we know that the number, so the expression changes to 2 cos x plus pi on 3. So all we do is we've got to change this, okay, to it's a single sine or a single cos. It doesn't matter, you got the choice. But once you've done that, then you just say equals 1, and then you solve the equation, which you've been doing in previous work. So the next line would be cos x plus pi on 3 equals a half. Okay, so when cos equals a half, now the function is defined between 0 and 2 pi on 3. Okay, so we've got a pi on 3 to add, so 0 less than equal to x less than equal to 2 pi, and then we change the function in the part in the middle. So now we've got pi on 3 to 7 pi on 3, and so cos is positive, so we have to check out the first quadrant, the fourth quadrant, but we've gone past the fourth quadrant, so we need to check the fifth quadrant to see if the answers are okay. Okay, so we've done that sort of work before. So we've got, so this is the bracket, so we've got x plus pi on 3. So in the first quadrant, for a half, we end up with, just checking my notes, so we end up with, for the first quadrant, we end up with pi on 3. For the fourth quadrant, we end up with 5 pi on 3, and for the fifth quadrant, we end up at 7 pi on 3. And then we just subtract pi on 3, so we get 0, 4 pi on 3, 6 pi on 3, so we get 0, 4 pi on 3, and 2 pi. And that makes sense, because once you have 0, you must have 2 pi as one of your answers. And that's it. And, next page, there's a worksheet on Moodle. So on this one here, I've got 3 different textbooks that I've put together, but you just need to do a mixture of questions. So I've done 3 different textbooks onto one worksheet. And so it just gives you plenty of practice, but you choose as much as you need to do. Okay, bye.